Okay, so this week we've got a couple of topics I want to cover before we make sure we go through and have everybody caught up for the end of the quarter. The first one is some special formulas that come into effect. We're going to talk about octagons. And the key term here is going to be regular. When we have a regular polygon of any sort, that means that all the sides are the same length. And all the angles are the same. So I'm going to try to draw this out. We're well aware of my artistic abilities here. Pretend that looks like a regular octagon. So, not horrible. So we're going to label the length of a side S. The distance across from one side to the opposite side measured at right angles, we're going to label F for as a flat distance. And then from one corner to the opposite corner, we're going to label D for diagonal distance. To find the area of a regular octagon, I can use any one of these three features. If I have the side, the area is just 4.8275 times the length of that side squared. And you might wonder, where does that 4.8275 come from? Well, it comes from trig. And if you guys were to go on into the program, that would be part of the second semester of math, would be the trig. For now, this is one of the few times I'm going to give you formulas and have you just accept that those are the ones that work. So if I have an octagon, a regular octagon, and let's say the length of the side is 8 feet. So that area is 4.8275 times 8 squared. Yep, the 8 times 8 is 64, you're right. 308.96 we get. And that's square feet. If we know the length of the flat, we can find the area as 0.8284 times that flat length squared. If you think of it, the flat length squared would be this whole big square here, so it makes sense that it's less than that. That's why it's 0.8284, it's less than 1. It's smaller than that whole square that it would encompass. So if we have a regular octagon, now we know that that flat distance across is 20 feet. That area is 0.8284 times 20 squared. What's that give us? What'd you get? Sounds good. 331.36. Okay. And if we know the diagonal distance, the area is just 0.7071 times that diagonal distance squared. So if we have this diagonal here of, well, let's say it's 18 feet. So area is 0.7071 times 18 squared, which will give us 229.10. We'll call it 0.10 square feet. Now you might be wondering, why is it necessary to be able to find the area of an octagon from all of these different dimensions? Well, an octagon actually comes up in construction way more than you would think. You guys look like you're building garden sheds? Okay. If you look at lawn features, a gazebo is a pretty common thing. In many municipalities, bless you, you have to be less than 100 square feet or you fall under building codes. So let's say you want to build a gazebo and you want to know, bless you again, it's probably dust being thrown off by the heater. If you want to know what length your side can be there to stay under that 100 square feet, you put 100 in for the area, you know it's 4.8275 times the length of that side squared, and we have to work backwards. Now I know we haven't solved equations yet, but we would divide by 4.8275. So what's 100 divided by 4.8275? So we're going to just go 20.715 for now. Notice I kept it in the calculator though. I'm going to keep it there for my next calculation so I don't have to punch it in. If I clear it out and type it back in, I'm rounding off every time I do that. So the more I can keep it in the calculator, the more precise I am. Now that's the length of the side squared, so how would I find the length of the side? Square root, exactly. So most of your calculators have an answer function. You can do second square root. Perfect. So with 4.551 feet is the length of that side. Now let's convert that into feet, inches, and sixteenths. So we know that's 4 full feet. What do I do with the rest of that to make it inches and sixteenths? There we go. We put that over 1 to convert it. We got feet on bottom, 12 inches on top. So yes, 0.551 times 12. 6.612. So that's 6 whole inches. What do we do with the 0.612? There you go. We multiply by 16, which gives us, so 9.7 is really all the further we need to go. The 9.7 tells us we're going to round to 10. So 10 sixteenths or 5/8. Don't feel bad. I was off in my morning classes today, too. I tried to say 240 minutes with 6 hours. It's amazing how long it takes for somebody to speak up when you make a stupid mistake like that, too. Now, 4'6" 5/8", basically 4'6". That's a pretty small gazebo. I don't know if you've ever seen the gazebo place in Elmina. They deliver a lot of gazebos. A lot of their stuff gets delivered in 2 or 3 pieces. So most of their stuff is 20 to 30 feet across. Is there one in Clear Lake too? They build and sell gazebos? Now, somebody told me the one in Elmina shut down. I don't know, but I'm not sure. I imagine the market's not real strong for them right now, but although you'd think outdoor stuff would be strong because you can't go into town and do things anymore. You'd sit in your yard. Who knows? The other one that I've actually done, I've had a few people that actually have requested this, to build an octagon structure, whether it's a gazebo or whatever it is, on an existing circular pad. Most of the time it's like an old silo or like an old corn crib, grain bin. And if that is 20 feet across, I need to figure out, again, what length the sides are going to be on that. So I can use these formulas kind of in tag team. Which dimension is that, S, F, or D, the 20 feet? It's D, it's corner to corner, it's the diagonal. So my area, 0.7071 times that diagonal of 20 feet squared, which gives us so 282.84 square feet. And now we work backwards to find the length of the side. So what formula are we going to use here? 282.84 equals careful, we're working backwards now for the side. There you go. Yep. Which gives us 58.95 or 959 is our side squared, and then square root it. Yep. So 7.65 feet on the length of the side. That's not bad. Let the corners hang over, you mean? It's awful hard to bond concrete in a small sliver like that. Like one house I worked on years ago, whoever did the footing for the walls screwed up. There's a good chance of that. The house, I believe, I can't remember the exact dimensions. It was supposed to be, let's just say it's 36 feet wide. Well, they mismeasured on one end and it was 34 feet. Now the footings still are supposed to be at least the thickness of the wall beyond the outside edge of the wall. Well, actually, technically, the footing's supposed to be minimum width is double the thickness of the wall. So if you're doing an 8-inch wall, this has to be a minimum of 16 inches here. I typically have always gone at least. No problem, it happens. I've always typically gone a little bit wider than that just to have some leeway. But even at 16 inches on an 8-inch wall, that makes this 34 feet 8 inches about. Still not wide enough to get your 36 feet in. Well, in order to add on to that footing, because you have to have a minimum of 4 inches outside the wall. So we had to go all the way back to here. Well, we couldn't just do a sliver here. We had to start at the corner, go out, and add a minimum of 12 inches on. I mean, and peg that whole thing. Yes, that had to be pegged the whole way. Oh, sure. Yep. Well, especially when it's on a footing like that, where you're down right tight to the ground trying to push at that angle. Yeah. The biggest thing is having a good drill. I mean, if you got just one of the small, like Menards hammer drills, you're going to be there forever. Yeah. Yeah, I have a good hammer drill demolition hammer combo, and that, unless it's really old concrete, it'll drill through it like butter, but it's heavy. So trying to keep it off the ground and push it in, and I only made that mistake once because it was an expensive mistake. Your arms get tired and it starts to tilt down. So you're drilling into the side here and you're trying to stay up high so that you don't have to get down in the dirt. I let it sag and I ended up popping up through here. That was not a good mistake. I mean, all it was you had to put in an epoxy. Feral Supply down in Eau Claire is where I go for stuff like that. And they have epoxies. It's just a 2-part mixture you mix together and you fill that hole. Then you just have to go on either side of it and drill new holes. Problem is all the other holes are already 16-inch spaces, so you've got to drill 2 to make up for that one. Yeah. Yep. Oh, sure. And I had that issue with a lot of tools. I did a lot of watershed projects, the concrete barnyards and walkways and manure pits and stuff. And so you're dealing in the sand. You get that sand in the brushes of your tools, and it's rough on them. Oh, sure. I at one time thought it was a good idea to invest in the pass load airless framing nailers with the LP and the battery. And yeah, those are not durable at all. The first time it slid out of my hand on a roof and went down and hit a sidewalk down below, it was done. So I'm going to have you guys try in your notes here. Let's say you know that you can get floor joists that are 24 feet long. find the length of the side of that octagon. If you've got your packet, Colton, these formulas are on page 170 of your packet. If you have your packet, the formulas for the octagons are on page 170 of your packet. That line, yeah. Okay. If you want to, yeah. So how do we find the area of this? Is 24 the flat, the side, or the diagonal? It's the flat, so it is 0.8284 times the 24 squared, which gives us an area of what? That's a formula out of your packet, page 170 of your packet. The formula is the area. So 407 point, we'll just go 29. Yeah, 29 we'll round it to. The area, if you know that flat distance, 407.2. 477? Okay. So the formula there, Logan, is if you know that flat distance from one side to the opposite side, it's 0.8284 times that flat distance squared. So now we're going to use that area to work the other way. So the area, if you know the side, is 4.8275 times the length of the side squared. So we're going to use that formula backwards. Oops. Well, what do we have to do first? We would divide by the 4.28 first, yes. Or 4.8275. What do we get there? 98.84. That's the side squared. How do we find the length of the side from there? Square root, giving us 9.94 feet is the length of that side. So just under 10 feet is going to be the length of our side. Just to practice, I'm going to have you convert that quick into feet, inches, and sixteenths. I'll give you about a minute or so, then we'll go over it. What'd you get? $11 1/4 inches. So let's check it out. The way we would do that with our calculator, if we have the 9.94 in there, well, the 9 whole feet we're going to take out because we've got the 9 whole feet here. So we just subtract 9 to get 0.94. How do we convert 0.94 into inches? Times 12. Good. Gives us 11.28, so that's the 11 whole inches. So again, we just subtract off the 11. And now it depends on what fraction of an inch we want it in. If we want it in eighths, we'd multiply by 8. Sixteenths, we multiply by 16. So times 16 gives us 4.48. So that's between 4 and 5. Which is it closer to? Careful. 4. So it's less than 4.5. It's closer to 4. So 4/16 or 1/4. So it is 9 foot 11 1/4 inches. Okay. Sure. And okay. And the way you did it is probably more precise because you didn't have to write it down and punch it in. Yeah, if you have it in your calculator, that's definitely the best way to do it, is to keep it in the calculator like that. So we're going to take a look here at having a 6-foot picture window with an 8-inch high arch above it. Do you guys remember how to find the radius of the circle that forms that arch? Yep. Pretend that looks like the rest of the circle. We know that height is going to be at the middle. So that cuts that into 2 3-foot pieces. Well, how many inches are in 3 feet? 36. So since the 8 is in inches, we want this in inches as well. So what we're actually going to find here first is this length here, which we're going to call x. When we have intersecting chords in a circle, they cut themselves into pieces that have the same product. So what that means is if we know the 2 pieces of one chord, and in this case we have the 36 inches and the 36 inches, that 36 times 36 is going to equal 8 times x. Well, rather than write it out like that, we're going to do this. 36 times 36 divided by that height of 8 inches. What's that give us for x? 162? So 162. X is 162 inches. Now from this, we can find the diameter of the circle. What's the diameter of the circle have to be? Well, it's 162 inches from here to here, but that's not all the way across the diameter, is it? 170, there we go. That was the 162 plus the 8. So that means the radius must be careful. You've got the right idea. So you've got the right idea. 85, there you go. So 85 inches for the radius. It's definitely got a pretty annoying rattle. What's that? You know, I haven't really listened to it in my recordings that much, so I don't know how loud it is, but it wouldn't surprise me. It sounds like the fan is pretty unbalanced, is what it sounds like. If you want to, you can go turn the thermostat down. It was set at 60 when I came in, so I turned it up. But yeah, if you guys want to turn it down, go ahead. So we're going to look at an opening here. Just use the arrows on the front there, should turn it down. So here we've got an opening that's 48 inches wide. And we're going to have an arch that goes up. Oh, let's have it go up 12 inches in the center. See if you can find the radius of the circle that contains that. Okay, so for this one, we start out, how do we find this? My circles are just lovely today. Yeah, if you got them to me by the end of the day Monday, that would work. Okay. Right here. So anyway, so how do we find x here? How do we find that dimension x? So 48 divided by 2 is 24. Then what do we do? Which gives us 48 inches. So x is 48 inches. That extra one makes a little difference. So what's our diameter going to be? 60 inches. That's our 48 plus the 12 for the arch. And so the radius is 30 inches. It just be divided by 13. It's going to be a decimal. Yeah. I'm trying very hard to keep these examples pretty neat for you, but yeah, they're not always that tidy. Even I can try to be nice now and then. Okay, so yeah. That's kind of the unfortunate structure of the 2-day-a-week class, is every Friday is kind of a quiz day. So for something like this, if I tell you that that side is 24 inches, and this is 30 inches, find the perimeter and area. I'll give you a couple minutes to work on this. We'll go over it and then we'll take our break. You guys are young. I don't want to hear about your sore backs. Wait till you're my age. You throw out your back just picking up your shoes. I can remember when I was young, listening to my friends that were older complain about stuff, thinking, you old farts. And now it's like, yeah, they were right. What do they do? Okay. Okay, so to find the area, we're going to divide that into two pieces, 1 and 2. The rectangle part is pretty simple to find. That's just 24 inches. What's this dimension? 6 would be this dimension here. That would be the radius of the circle. So the diameter would be 12 inches. So that's 24 inches by 12 inches is 288 inches squared. Now that's a half circle. We treat it as a full circle to start. How would we find the area of a full circle? Pi times 6 squared. And of course, it's half a circle, so we divide it by 2. What's that give us? No, because you divide the radius, you divide the radius in half, and the squaring kind of undoes that. But you get 56.52. Yeah, if it was circumference, that works. But for area, because it's a radius squared, you can't just cut the radius in half. So that adds up to, what, 344.52 square inches. Perfect. So there's our area. For a perimeter, we're just going to pick a spot and work our way around. So I'm going to start here just because that puts the circle part last. This piece is 24 inches. This piece is 12 inches. This piece is 24. And then we have to find that half circle. How do we find that? Well, the circumference of a full circle would be pi times diameter, would be your circumference, right? So pi times 12. It's a half circle, so we divide that by 2, which gives us 18.84. So we add that all up, that is what, 78.84 inches of perimeter. Okay, we're actually 1 minute late for break. Go ahead and take your break. We'll come for this next one. We're going to look at a tank. Kind of like an LP tank. We're going to say that's 8 feet there and 12 feet there. So this is a little bit larger than your standard LP tank. Yeah. Total length is about 8 or 9 feet, yeah. Total diameter is usually 3 feet on a LP tank too. So to find surface area and volume, let's find the volume first, just because that's usually easier. This is one where it pays to take it apart and put some pieces back together. If I cut off the half spheres on each end, I can put them together to make one big sphere. What's the radius of that big sphere? What's that distance? There you go. It's 2 feet on each end, so it's a 2 foot radius. 4 foot diameter. There you go. So the volume for a sphere, circumference is just pi times diameter. So volume for a sphere is 4/3 times pi times that radius cubed. No, it's not. So we have 4 divided by 3 times 3.14 times that radius of 2 to the power of 3. We get 33.49. And that's going to be cubic feet. Now for the cylinder portion, how do we find the volume of a cylinder? Does anybody remember? We start out with the area of the base. Yes, well, we're assuming that it's a paper-thin surface. So to find volume for most solids, the sphere is different because it doesn't have a base. For a cylinder, it has a base. So we find the area of the base, which is just that circle. How do we find the area of that circle? 2 squared, right? So that's 12.56 square feet. And so the volume is the area of the base times the height. The height is just the distance from one base to the next. So that's 8 feet. So 12.56 square feet times 8 feet, which is going to give us 100.48 cubic feet. We add those up. We get a total volume of 133.97 cubic feet. Surface area. When we have composite shapes like this for surface area, the trick is figuring out what surfaces are exposed. Normally for the surface area of the sphere, surface area of the cylinder, we would have 2 bases. Well, here both bases are covered by the half sphere, so there are no bases in the surface area for the cylinder. I don't know if you remember, but we talked about area of the base and we talked about lateral area. The lateral area is the area connecting the 2 bases. So for that cylinder, for surface area, all we have is the lateral area. The lateral area is the perimeter of the base times the height. Well, the perimeter of the base is the distance around the circle. How do we find the distance around the circle? That's the circumference, which is pi times diameter. Good, and that diameter is 4 feet. So pi times 4 is 12.56 feet. So that lateral area is 12.56 feet times that height of 8 feet, giving us 100.48 feet squared, is the lateral area for the cylinder. Now we need the surface area for a sphere. Does anybody remember the formula for the surface area of the sphere? It's 4 times pi times radius squared. So 4 times pi times 2 squared gives us 2, yep. Is it 100? I'm getting 50.24. All right, 50.24. So we add those up, get 150.72 square feet. You must have squared the 4 instead of the 2. Yeah. Okay. That'll do it. So we get a total of 150.72 square feet of surface area. This is something that we'll practice more as things come up here. Now, I gave you guys a quiz last week that I want to take some time to look at. Yeah, for the diameter and the length, you guys tape measure. So the big one I want to talk about is number 2. Yep, go for it. We'll wait for you here. Okay, so we're asked to find the amount of trim it would take to go around this half circle or semicircular window. The tough part is it says to allow 2.5 inches at each corner for the miter cut. So the first thing we need to do is find the perimeter around this. So I'm going to find the distance around this half circle first. To do that, it's easiest if I convert this all into 1 unit. I'm going to convert it all into inches. 6'8", how do I turn that into inches? 6 times 12 is 72, plus 8 is 80, so that is 80 inches. Now, how do I find if that were a full circle? The circumference would be found by doing what? So pi times 80, which would give us 251.2 inches. Now, of course, that is only half a circle, so we divide by 2. Perfect. So that is the distance around the semicircular part. What do we have to do to finish off the distance around that? Yeah, we have to add this side here, the 80 inches. We add 80 inches to that, what do we get? There we go, 205.6 inches. Now that's the perimeter of that window, but that's not our total trim here. We have to look at that 2.5 inches at each corner for the miter. Most trim is 2¼ inches wide. So that's why we say 2.5 inches for a 45-degree miter. You're really only losing 2¼ but you give you that extra 1/4 inch to work with. Now there's only 2 corners here, but each corner has how many miter cuts? 2. This piece of trim comes like that, there's a miter cut there, and this piece of trim comes like that, there's a miter cut there. So there are how many miter cuts here? 4. So 4 times 2.5 inches is how many inches? 10 inches. So we add that to our 205 to get 215.6 inches. Now we need to convert that back into feet, inches, and 16ths. Well, we divide by 12 would give us 17 feet, yep. So now we're going to do what here? I did 215.6 divided by 12. Gotcha. So 0.9666666, how do we turn that into inches? Times 12, good. Yep, so it's 11.6, that's 11 inches. So we've used the 11, so we're going to take off the 11. We've got 0.6 inches left. What am I going to do with that? Times 8, because we want it in eighths. So 4.8 is going to be 5/8, right? 4.8 is closer to 5. 17 feet, 11 and 5/8 inches. The other one I wanted to go over on that quiz is number 15. .29 feet, we want it in inches to the nearest 1/8 inch. Now, if you did 4 feet and just converted the .29, I'm okay with that. But you could do the 4.29. How do I turn that from feet into inches? Times 12. So I have 51 inches. What do I have to do with that to get the eighths? Yep, I got to subtract off the 51 and then the 0.48 times 8. So that is how many eighths? 4/8 or so 51.5 inches that comes out to be. Any questions there? 14, the dimension for B. That one's loads of fun. There might be a little sarcasm in that. A, you're just adding the 3 dimensions. Yeah. It's like I tell all my classes, you guys are here to entertain me for 32 weeks. That's what matters, right? Yeah, you guys are here in the spring too. In the spring, it's just on Fridays. Well, what we have to do there is we have to figure out what the distance is from here to here. The difference between 28.8 and that distance is going to be B. So to find that distance, that's the same distance as from here to here. Well, that's the difference between the 34.4 and the 12'6". We're finding this distance right here. So it's 34'4" minus 12'6" inches. Well, 4 minus 6 can't be done, so what do we have to do? Borrow. So this 4 becomes a 3. This 4 becomes 16. There you go. Adding 12 inches. 16 minus 6 is 10 inches. 3 minus 2 is 1. 3 minus 1 is 2. So that's 21 feet, 10 inches. So this is 21 feet, 10 inches. So now how do I use that to find B? 28 feet, 8 inches minus 21 feet, 10 inches. So 8 minus 10 can't be done, so we borrow. This 8 becomes a 7. This 8 is going to become 20. 20 minus 10? 10 inches. 7 minus 1 is 6, and of course 2 minus 2 is nothing, so it's 6 foot 10 inches. Did you do it as 34.4? Oh, sure, that works too. Yeah, so you would have done 28.8 minus 34.4 and then add 12.6 or something like that. Any others that you have questions on? Okay, so that will not be due until next Friday. I do have. Those may have already been behind us. Actually, I have an extra credit quiz I'll give you here that's not so bad. So I drew this in a different orientation. It's not me being sneaky, it's just me not looking at the diagram before I started drawing. But this is just number 3. We're trying to find the area of that little sliver there, the one that I colored in black. Now remember, to find the area of that, that's called a segment. We find the area of the whole sector. Do you guys remember how to find sector area? It's the area of the whole circle times the angle over 360. So we need to know this angle here. Now, I didn't give you the angle, but from the sides of the triangle, we can assume that angle has to be 60 degrees. It's an equilateral triangle. And then from that area of the sector, you're going to subtract the area of the triangle here. We don't have any right angles for that triangle, so to find its area, you're going to have to use Hero's formula. So for that triangle, the perimeter is 30 inches, so the semi-perimeter is 15. So the area is the square root of 15 times 15 minus 10 times 15 minus 10 times 15 minus 10. Remember, it's the semi-perimeter times the semi-perimeter minus each side. Since all the sides are 10, those all end up being the same. There you go. I'll let you guys take that one from there. Number 5. I'm going to use a different number. "16 square feet going into square inches." You're got a good train of thought there. To convert from square feet to square inches, how many square inches are in a square foot? There's 12 inches in a foot. Square is 12 by 12, which would be 144. There you go. So it's 16 times 144. Yeah, it's not the same number, but it's the same process. So you have 32 square feet instead of 16 square feet, but that's the process you would need to use. Yeah. For number 6, we got, oops, go ahead. For number 5, it would still be times 144, because it's still square feet and square inches. Yeah, it'd be 32 times 144 instead of 16. You got kicked out of the academy? Eight square yards. 1 times 9 is 9, so we divide by 9. What'd you get? Yeah, for number 6, yeah, I got 72 for this one, but number 6 is a smaller number, so. Yes. For number 7, .2 meters squared going into centimeters squared. Well, we've got decimeters, meters, decimeters, centimeters, and millimeters. To go from meters to centimeters, it is 2 spots to the right, which would be times 100. But this is squared, not just meters and centimeters. So it'd be times 100 squared, or 10,000. Each spot on the chart is 10 squared, or 100, which makes each spot on the chart 2 decimal places. So 2 spots on the chart is 2 times 2, or 4 decimal places. Adding the zeros would make that 32,000 centimeters squared. For number 8, going the other direction, 2 spots on the chart, so it has to move 4 decimal places. So just move your decimal point 4 decimal spaces to the right. So you got to fill in some zeros. Well, it's millimeters now to meters. That's 3 spots to the left. Each spot, since it's squared, is 2 decimal places, so it's 6 to the left. So it's 0.0438. So you should have a pretty healthy start on that one. Is there anybody that has any corrections that they want help with today? I wanted to make sure I reserve some time to do any corrections. We're all good on them? Okay. So there's one last example I want to do before we get out of here. I'd rather have you hold on to it so I don't have... What's that? Yeah, that's fine. You guys know my email address? Yeah. todd.hoff@witc.edu? Yeah. Okay. Pretend that looks like a quarter circle there. So let's find the area of this. This is one where it's probably easiest to fill in the missing corners. Find the area of the big rectangle first, and then subtract out those missing pieces. But we need to know what the dimensions are. It is 20. This up here, 8 plus 12 is 20 inches. That's good, Logan. How do I know? I either need to find this dimension or this dimension. Yeah, I know. I changed it to inches just to be tricky. Sneaky. Yeah, I just changed it from millimeters to inches and did the mirror image. So we've got 20 inches all the way across there. What's that? Yeah, that one's in millimeters, but mine will just be in inches instead of millimeters, so it'll be the same number. Yeah. Here we can find this dimension. What's that dimension have to be? 6. Good. 20 minus 14 makes that 6, which means this dimension has to be 6. So that rectangle is 20 by, because that's a half circle, so it's the same in both directions. So yes, 20 by 13, which makes that how big? 260, there we go. So 20 times 13 is 260 square inches. Now we need to find this dimension so that we can find the area of that triangle. What's that have to be? Yeah. This has to be how big? 4. So how do we find the area of that triangle? 4 times 8. Then what? Divide by 2 because it's a triangle. So that's 16 square inches. We subtract to get 244. Now, how do we find the area of that quarter circle? The area of the whole rectangle minus that triangle that's missing. Quarter circle is just the area of a full circle divided by 4. How do I find the area of a full circle? What's that? So I just got to find the area of that quarter circle. So it's the area of a full circle divided by 4. So the area of the full circle is pi times what? 6 squared. Good. And then since it's a quarter circle, we divide by 4. So what's that give us? What's that? 28.26. So we subtract that to do 215.74 square inches as the area. So now, of course, yours is just a little bit different, but I think you can figure it out from there. Number one, you have a triangle with three sides. There are no right angles there, so you have to use Hero's formula. Number two, Hero's formula, that's that find the perimeter, and find the semi-perimeter. Then the area is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. That's what I usually do. It really doesn't matter, but I usually go longest to shortest. What's that? Sure. That'd be for number one and for parts of number three, for doing the triangle in number three. Then, of course, for number two, it's just the area of a sector. So this is for number one. So remember, sector area is the circle area times the angle over 360. Anybody have any questions on that? You would find the area of that whole circle. Nope, it's a little bit smaller than a quarter circle. It's 84 degrees out of 360. So you find the area of the whole circle, and then instead of dividing by 4, you just multiply by 84 over 360. Yeah, so that angle there is 84 degrees, so it's 84 over 360.